Welcome to Main Street Minds with your host, Amish Munshi. This is where industry leaders and seasoned pros share their secrets to success beyond limits. Let's dive in.
Hello and welcome to Main Street Minds. Today we have a very special guest, Anand Nagarajan, with us. I'm excited to meet him. He is working on something extremely exciting. In addition to having a PhD in simulation from Ohio State University, he is actually practicing that and what is involved in making decisions before a new product or anything new is launched. The it's important to have a concept and a mindset and a framework to be successful at doing something. So before we achieve anything, we need a plan. And after going from a plan to an actual prototype, there is simulation in the middle, right? So before anything happens, before innovation happens, Anand helps us ensure that it's actually a good product and prototype to even start working on. So let's dive into the exciting world of simulations with Anand Nagarajan today.
Well, thanks for having me here, Amish. I'm really excited to speak with you and your viewers today, and hopefully I can offer some insights. And thanks for that lovely introduction. I am Anand, and I'm a computational scientist. I work in the design verification technologies wing of the Siemens EDA,
Mhm.
um, and we actually work on the Questa One software that helps to test and verify semiconductor chips before they are sent out for manufacturing. And my work specifically, it focuses on functional safety, where we want to test and verify the chip when see if it behaves the way it is intended to, if it is able to handle test edge cases as well as like um, detect faults and like how it can handle such situations. That's what I do right now, but my journey actually began in a completely different world. If I look back at what I was interested in 15 years ago or so, it would seem like a completely different world from where I am today. But I feel like it has actually been a very rewarding journey and a list of small natural progressions. So even though from the bird's eye view it looks like a completely different world, I feel like everything that has happened makes sense and it's been really richly rewarding.
Yeah, that is amazing. So, what got you interested in chip design and the analysis of it?
Yeah, actually, this whole thing started off in a completely different world.
Mm-hmm.
So I was in India during my undergrad in mechanical engineering at IIT
Mm-hmm.
Bhubaneswar. And what changed my world is a course in finite element methods that I took in my final year.
Mm-hmm.
And this was taught by Professor Panigrai, who I respect a lot. And he really changed the way I look at um, like engineering. And this subject basically gave me insight into looking at um, how complex mathematical equations can be used to model physics and like how that can be converted into computer code that can be run in the blink of an eye. So
Mm-hmm.
that combination of math, physics, and computation, like it stuck with me. But at that time, I was actually more focused on um, like material science and like how the material behavior can be modeled and like how things deform under load. So
Mm-hmm.
when I moved to the US in 2012 to start my graduate school journey, I actually took up a project um, on like understanding like the behavior of like stainless steel in like the hot forging of like stainless steel in creating pipe fittings.
Mm-hmm.
And that's when actually I was introduced to commercial simulation software. And that actually opened up a curiosity in me. And I thought about like, okay, how do these softwares work? Like what's
Yeah.
happening underneath the surface? So that thought was rumbling inside, and Well, and then I decided like that kind of hate myself, so I'm not gonna stop at a master's, so I'm gonna continue a PhD.
Mm-hmm.
So I switched my research focus to computational mechanics, which is the art of like creating these sort of like computational softwares.
Mm-hmm.
And I did the jump and started my PhD with my advisor. At
Mm-hmm.
that time, it was actually very intimidating because I had no formal coding experience, and I struggled through my first C++ programs. Uh, Although it was difficult and intimidating at first, I felt like that was like it gave me a chance to step out of my comfort zone and learn something new. And like that pivot at that time basically became very meaningful and shaped everything that followed later. And once I finished my PhD, I
Mm-hmm.
actually took up a job at ExxonMobil, and I was working on their reservoir modeling tool and like using computational methods to offer like insights on the subsurface modeling of like their oil and gas reservoirs. And at that time, like I didn't expect what was going to follow, right? This was the year 2020.
Oh
And
yeah. Yeah.
so I think someone somewhere decided I'm having too much fun. Uh, so let's spice things up a bit. So of course, COVID happened and like the entire world shifted in the blink of an eye. It
Yeah.
kind of hit the energy sector particularly bad.
Yeah. Yeah.
So what happened at that time, I was sort of concerned like what's going to happen like at the end of my term because I had joined ExxonMobil as a postdoctoral researcher with a one-year
Mm-hmm.
term. And
Yeah.
I asked my manager at that time, like, okay, like, what's the situation going to be like? And I appreciate her candor at that time. And she mentioned that, okay, the company is not in a good shape right now because of uh, like the COVID-19
Yeah.
situation. So we cannot guarantee like a position for you at the end of your term. So please look out for yourself and like do
Yeah.
what's right for your career. So
Yeah.
I continued to work there, but at the same time, I was looking for the next thing to do.
Mm-hmm.
And that's when I came upon this position at Cadence. And life can be funny at times. Cadence had actually reached out to me the previous year and
Mm-hmm.
regarding a position in computational geometry, creating meshes, like which is what I did during my PhD. I
Yeah.
like politely declined at that time because I had already given my word to ExxonMobil that I'm joining.
Yeah.
And this time around, like it actually felt like things were lining up.
Mm-hmm.
And it was actually much more closer and like aligned to what my interests and like my expertise was at that time because this was
Mm-hmm.
actually in the thermal solver team.
Mm-hmm.
And me being a mechanical engineer, having a computational mechanics background, um, it gave me the chance to jump in and provide value and insight into thermal simulation while at the
Mm-hmm.
same time entering the semiconductor industry and like learning about electronic design automation and design and manufacturing of chips. So over time I built up that base, and last year I decided like it's time for a change at that time, and I moved over into design verification side like with Siemens. And I could probably spend like an hour like talking about like the different aspects of EDA because like it's a very complex multi-stage process on how an idea then actually ends up becoming a like a physical
Yeah.
chip,
Yeah.
right? So I feel like it's always good to know the big picture as an engineer,
Yeah.
and
Yeah.
you don't want to be like putting blinders on and just focusing on your work like within the business as well as like the technical context. Like you want to understand like where your work actually fits in, and like you see the big picture. That's how you become a better engineer and like you can provide more value. So moving over from like the physical design verification focusing on electrical thermal simulations
Mm-hmm.
during sign off, and now moving all the way to the um, upstream part of like chip design, looking at design verification. Like it felt like a great opportunity, and I've been loving it so far.
Yeah, it's amazing, right? Like the important key points that I can gather from that is, yeah, you should have goals, you should have passionate, you should have discipline to do something that you're working towards, but also always be open. Life life is weird, like it throws a monkey wrench right when we don't expect it,
Yeah.
and there shouldn't be an ego saying, "Hey, I denied something, and why will I accept it later?" Things change. Take it professionally, have goals, work towards them, and more importantly, whatever is interesting you is the like follow the path of what you're interested in. Like I think that if I have to like kind of pick up a few points from everything that you mentioned, I think that kind of summarizes like how you reach the level of success you are at.
Yeah, I do feel like the main thing is like you have to be open-minded.
Hmm.
And I wish like that was a lesson that I had learned like a bit earlier in my life. Okay, but like I think we all live and learn.
Exactly. Yeah, and that's the best part about this, right? Like other people will be able to learn from this thing. Hey, how to like how, you did become successful, but if you were not open to making changes, it could have led to a very different path. Like it could have left. You could be still be doing the same work. You might be your heart might be in one place, might but you might be working on something else. So. Yeah, so that brings us to like just the a little more detail about what you're doing. So like on one side, we are all like out from coming from outside, we are always amazed at like just we are almost at like atomic level size on the chip design, right? How like what is even possible to be designed at that level, and what is the future?
So of course, like I think people are sort of familiar with like Moore's law, and like the transistor chips become more and more powerful like every year. And
Hmm.
people thought that like we are reaching a limit, but like we are actually finding ways to break that.
Yeah.
And 3D IC is a trend where like we are actually stacking different chips vertically inside a package, and like being able to generate like even more high power devices.
Hmm.
And that's actually like exploding the complexity of the design process. And there is a whole host of like interesting technical problems and like opportunities right there for somebody in the EDA space to work on and like offer
Hmm.
value. But that aside, like the power it actually gives for people who are designing these products, because we can get so much compute power at such a small area these days. Like it lets you do these things that were probably unimaginable a few years earlier, right? And
Yeah.
one general trend that I'm seeing right now where like everybody is heading towards, and I'm actually gonna focus a little bit more on the simulation space because like
Yeah.
that's where my domain is, right? So if you look at the autonomous vehicle space, for example,
Hmm.
right? They are actually having like this like large scale like simulation farm where they're having like different weather patterns or like traffic scenarios or um, stoplight situations, etc. That you would want to like run that through simulation, because like real world data collection, hey, it's probably not going to be possible to cover all the different scenarios. And sometimes you don't want to simulate certain scenarios as well, right? Like for safety
Yeah.
purposes. So you
Yeah.
would want to create a digital twin and actually simulate that. And because of like how complex this can get with all the different scenarios and how detailed you want to get the model, like you would want to simulate that on like a high speed like GPU cluster, and like
Hmm.
you would um, then use all that simulation data to then like train a model. And now that model actually is so lightweight, it can go on a small chip inside your car, and then like you can um, have that chip tell your car how to drive.
Yeah.
Right. So the what is happening is like we are using the advancements in computing GPU acceleration, the availability of these cloud servers to
Mm-hmm.
do more and more simulations at scale.
Mm-hmm.
And that is allowing us to get so much data and design insight that that's actually then fed to a model, and then you can put that into a small chip. And like we already talked about, like how like with 3D IC and like how the you're putting more and more power inside a chip with the
Yeah.
TSMC 3 nanometer recently, right? So
Yeah.
this can actually go into a small device, like either inside your car or inside your phone or like your computer, and you are able to get a lot of like actionable um, like
Yeah.
value from like your AI assisted device because it
Mm-hmm.
has the backing of all those training data that like it has been fed into, right?
Yeah.
And that's
Yeah.
where like the world is headed.
And is the future going to be even like even smaller chips, kind of even like 3 nanometers is where we are right now, right? Is there a possibility of going even more smaller than that?
They're always pushing the boundaries, so
Yeah.
I would not be shocked at all.
Yeah. Okay. Okay. So, like theoretically, at least it's possible to go smaller. I was just wondering, like, we are almost like we are designing stuff at atomic level. Like, how do you go smaller than an atom?
Yeah, I mean that's exactly why like people are thinking out of the box.
Yeah.
Like so it's not just about um like just shrinking
Yeah.
like your 3 nanometer process down to something even smaller, right? It's
Okay.
also about like how you smartly use this
Yeah.
use the design space, right? And that's where like 3D IC comes in, like where like
Hmm.
you're actually stacking multiple chips on top of each
Makes
other instead
sense.
of like packing
Yeah.
everything into just one chip.
Yeah, I think it's going to be that same. I get. I might be completely wrong, but that same concept that we had, like we had a single-threaded processor, and then we said, okay, how do we scale this thing? We went with multi-threaded and multi-processors, and kind of made our life a little more sophisticated to enable the ability to do more.
I mean, that's a very smart parallel, right?
Yeah, yeah. It's just it's definitely not related, but yeah, just kind of a state of mind. It's like, hey, how do we do something more with the resources we have?
You may think it's not related, but like it is in a way, because I
Yeah,
think the solutions, like nobody is really like reinventing the wheel, right? Like you try to
yeah,
get inspiration from somewhere else, and then like you apply that to the problem that you're solving in your
yeah,
day-to-day life.
yeah. I just hope software manages to keep up with everything that's happening. Yeah.
Absolutely.
Yeah, because it's on one side there is a lot of investment happening in the software. There's a lot of investment happening on the hardware, and then I think if there is a little more synergy, like the phones can easily replace our laptops at least right now, and but that combination of that coming together has been very painful, right? Like everything that people have been trying to do. Microsoft has been trying to push an ARM chip for 12, 10, 12 years, and it's still struggling. Right. So that whole integration that needs to happen, and then obviously Mac did it, but then it's a limited world, right? Within its own capability, it can't just become open as well as much as others can. So I hope there are like more standards that come into play. There is more collaboration that comes to make things work together. And whenever there is some new innovative way of doing something, I think we need standards to come in.
Yeah, I mean to touch on the point that you just mentioned over there, I feel like we are already there. Like
Yeah.
there's very few reasons why you would actually need a personal computer right now. Like I mean, your phone can pretty much do most things,
Yeah. Yeah.
and it's not just your phone. Like think about like your smartwatch and like all the capability that's in there right now. And of
Yeah.
course, like people are talking about adding more and more capability to augmented reality glasses. Like Meta
Yeah.
have done this thing with Ray-Ban right now, so uh,
Yeah.
it's going to be very interesting how where the future goes.
Yeah, yeah. I was about to ask, like, where do you see the next step? Like, what do you see happening in the next 5 to 7 years?
I would say you would probably get like a lot more automation. And I
Hmm.
think that's one of the um, m- like bread and butter like use cases of AI, right? And again, I'm going to go back into the simulation well
Mm-hmm.
and like use an analogy from there. So going back all the way to 2015, when I was working in the automated computational mechanics laboratory at Ohio State University, my professor, Professor Grady, like his
Mm-hmm.
vision was to have the complete automated pipeline
Mm-hmm.
going from having an image of a engineering material like a composite material, like you would
Mm-hmm.
scan and take like an image and create like a digital twin, like a virtual representation of that.
Mm-hmm.
And then you would automatically
Interesting.
create a mesh and then run simulations on it.
Yeah.
And that simulation then gets into like a model that is then trained to give actionable insights. So what's actually happening here is the fact that like you are increasing the speed of um,
Yeah.
the design phase by automating a lot of things that were like long and cumbersome
Mm-hmm.
previously. And now with the power of AI actually becomes a force multiplier. So when
Mm-hmm.
somebody is sitting and designing something, they can actually use AI to get real-time actionable insights. Of course, it's not going to
Mm-hmm.
replace the physics entirely, but it
Yeah.
can guide you. It can tell you, hey, this is probably a test that you need to run. This is like a hotspot that can be that you may be expected to find in the design, and like it can guide you, right?
Mm-hmm.
And you can use that analogy and then like map it out to whatever is going to happen with all our like daily like devices. Like you're
Yeah.
already seeing that with your smartwatches, right? Like you
Yeah.
have all the data, like it's actually tracking your sleep, it's tracking your heart rate, it's tracking your energy levels, like,
Mm-hmm.
and you are going to have the AI inside that device use all that data and tell you, hey, you probably need to drink some water right now. And
Yeah.
you need to take a 15
Yeah.
nap.
Yeah.
So I think you can actually build a lot of devices that are going to provide a lot of value to people. Now, the challenge is going to be like, how can you make it cheaper so that like it can reach as many people as possible, right?
Mm-hmm.
Like this is not as exciting if only like a select percentage of people can actually have access to certain devices.
Yeah.
I guess like I hope where the industry heads is like um, goes towards like making those devices cheaper and cheaper so that they become more accessible to more
Mm-hmm.
people. Well, at least that's
Yeah.
what I hope.
Yeah, yeah, makes sense. Yeah, so I think that is a extremely like on one side, I think there's going to be more of specific use cases, and I think on the other side, there's also going to be a little more collaboration and kind of what we call it today as an app or a software. I think that's going to become a platform. Like as an example, like if I want my laundry done, I might have a robot that will just automatically say, "Hey, Uber, you figure out what's the best way to get this thing from here to the laundromat." Right? And then it might be an automated platform, but Uber might. I'm just giving an example, right? Not no, not just a first name that came up on my mind. It might be Uber, it might be somebody else. But that Uber might become like just a platform and an algorithm to design like how to move things around between places. Uh, Instead of it being an app, it might be a platform that integrates with other things.
Oh yeah, absolutely. Like the world is just getting connected more and more,
Yeah.
right? So um, you can have like an Uber app that is like in some ways they are already
Yeah, they're
like
doing it
adding
for
value there, right?
food.
Like it
Yeah,
started out as food delivery.
yeah,
Now it's doing groceries for you as well.
yeah,
So
yeah,
they're actually trying to expand and like basically become like this logistics partner as opposed to just your food delivery app,
yeah.
right?
And it's crazy because I was just thinking about it. Like one of my relatives just moved between states, and I'm like, they've left some stuff here, and it's very expensive to ship this, and it's the stuff that they have left is not as important to pay like $1,000 to ship. But it's like, but if it was a moving company taking it, it was not going to be that expensive. So like just as an example, right? Like if it's not really $1,000 to ship two boxes from between two states. But and there are trucks that are going, and some of them are even empty. Like there is space on it. So just those logistics can kind of. I think there's going to be more fine-grained services that will be available, and the what is being used as an app right now will become a platform. Anyways, I've completely shifted
No, no,
topics
I really liked what you touched on that
into
because
the
like
life aspect of it. But yeah, going back into at the designing level, right? So do you see like any overlaps happening with quantum as well, with quantum computing and traditional binary computing that we keep doing all the time?
that's not an area that I'm like super
Sure.
familiar with. So I don't think I will be able to like
Okay.
offer like
Okay.
any
Yeah,
deep insight on
and
that.
that is also a very valuable insight because I know like it's completely separate, but if you have also not come across something, that means it is still completely separate. There is still not as much overlap.
Yeah.
Yeah,
Like I'm sure there's people like who are working in EDA or like industry that is like similar to mine, like that are
yeah,
probably experts on that. Like me particularly, like I have not actually worked on
yeah,
it or like have any sort of like opinion or like knowledge on that.
yeah. Makes sense. So tell us a little bit more about yourself. Like what just about outside of the technology space. Like what do you like to do? Where do you see yourself in a few years?
Absolutely. So I like to like be active. Uh,
Mm-hmm.
I get a lot of joy and enjoyment by going to the gym, lifting weights. I
Yeah,
also like to spend some time like training for like um, 10Ks or like maybe in the future I can consider even doing a little bit more. So
yeah,
it's sort of like a stress buster. Helps me grounded like and keep myself calm and composed in
yeah,
other aspects when life can get hectic.
yeah.
I like playing guitar, so I like to make time for that as well, as much
Yeah.
as like the busy lifestyle um, allows me to. Well, I shouldn't be saying that. I recently read a book. I think maybe some of the other guests in this podcast also might have mentioned it. It's called Atomic Habits by
Yeah,
James Clear, and
yeah.
like it tells about showing up in consistently. This is more important than
Mm-hmm.
actually being able to do something justice and like thoroughly like you would imagine. Like I would say like, oh, I only have like 5 minutes or 10 minutes right now. Maybe I shouldn't be picking up my guitar. No, it's actually important. If you have
Yeah.
5 minutes, just pick it up and play for 5 minutes. Like that way, you're at least consistent and like you're creating a habit.
Mm-hmm.
And I think that's something that I'm trying to incorporate in my life as well.
Yeah.
And another thing that I'm learning and becoming more and more aware recently is like uh, how important like communication is. Of course, on some level, I already knew that,
Mm-hmm.
but I think it's good to put an additional emphasis on that. So I recently joined um, like Toastmasters International
Mm-hmm.
after like some suggestion and encouragement from like some of the close people in my life. And I think that's been really rewarding. Uh,
Yeah.
I like to be put in a spot and like like to communicate like on the fly.
Mm-hmm.
And I don't think I had the confidence or the ability to do that well, and I'm trying to improve on that. And
Yeah.
that can actually translate into success in your work as well, because I
Yeah.
think the better you communicate technically, you are able to actually collaborate with people effectively. You are able to
Mm-hmm.
lead other people effectively, and that's how you can get sustainable growth in your career.
Mm-hmm.
And I don't take those type of opportunities for granted. Uh, Earlier this year, Siemens gave me the opportunity through my manager. He asked me, "Hey, can you actually take on fresher onboarding and like teach them this particular topic?" I think earlier in my life, I would have been like, "Hey, are you sure like I'm the right person for this?" Like, I've only joined like 6 months ago. Like I'm quite new.
Yeah,
Like I don't know if I should be the one doing it.
yeah,
But like with all the recent shift in mindset that I'm trying to create for myself, I'm like, absolutely, I'm going to do it. And
yeah,
of course, I had no idea how I'm going to do it when I said yes. But then I knew that ChatGPT was going to be my friend.
yeah,
Uh, I'm saying ChatGPT, but like
yeah,
basically any LLM that you can use,
yeah.
right? And
Yeah.
I would say like if anything, people listen to this particular episode, if there is going to be one takeaway, um, I would like to tell people, hey, be brave and like just step out of your comfort zone, especially now with all these LLMs and like ChatGPT and Claude and everything that is available to us. Like you may not go from 0 to 100, but you can probably go from 0 to 25
Oh,
really
yeah,
fast.
yeah, yeah,
And in a lot of situations, that's all you need to get the ball rolling.
yeah.
And that being part of fresher onboarding and like being an instructor in that was like very rewarding for me. And I personally feel like training and mentoring people actually helps me learn faster.
Oh, yeah,
I'm
yeah,
always like looking for opportunities to do that, and I
yeah,
pestering my management to give me more and more opportunities on that. So I think that's
yeah.
the space that I'm trying to grow in right now.
Yeah, I would 100% agree on that. I think the best way to learn is to start training on that same thing. Like you will there have been so many occasions where I've been blessed to be the trainer on something, and I'm like, I have figured out everything about that topic because I'm like, I have to train on this thing.
Yeah.
Yeah. Cool. So that is like an extremely valuable insight, and like it's very very useful for anybody listening. Saying how like it's the I think finally it's the mindset that transforms everything, right? Well, first thought is like first there is a concept and a thought, but for that concept and a thought to come into play, it's the approach in which a person thinks makes the biggest difference, right? So the way the person thinks will enable them to open and be create new innovative ideas. And after that, the discipline is required to like actually ensure that it actually happens. And with that atomic habits meant thing that you mentioned, like yeah, like on one side we should be open to doing something new, and then the atomic habits saying, hey, don't try to boil the ocean or change the world at a go, right? It doesn't happen. I don't know why most more people don't use electric vehicles. Like it just makes sense to me. But uh, just like the cost of owning it or everything, it just doesn't make sense to like do something else. But it's not easy to change the whole world. It's like it's been painful to make the smallest of the changes to the most sensible solutions in this world.
Maybe if you allow me a cricket analogy,
Yeah,
don't try to hit a six of every ball, right? Like,
yeah,
um, rotate the strike, like keep the scoreboard ticking.
yeah, and more than likely you're going to reach the same target.
Exactly.
Yeah. So sounds great. So as we come to the end of this episode, any other final tips or recommendations you have for the viewers?
I would say don't neglect your health.
Mm-hmm.
Um, I think we have to understand that this is a marathon and not a sprint, and
Yeah.
burnout can be very real. So if you have like some sort of like self-care routine or something that gives you
Mm-hmm.
joy, uh, don't forget that as well. And that's actually going to help you sustain and hopefully have a long and successful career.
Yeah, yeah, that is extremely valuable. So thanks for mentioning that. I think even before the mindset comes health, right? Like if if you're not in the best health, you're not even thinking about the right things. So I think that's where everything starts. So definitely take very good care of your health. That relates to success in life, right? Like life is meant to be exploring, and to do that first of all, you need right thoughts, and the right thoughts come with focusing on the right things.
Yeah, absolutely. I think I heard someone say you may have 999 problems in your life, but if your health is failing you, you actually only have one problem in your life.
Yeah, yeah. And it's not good to have less of that.
Yeah,
That like you should probably have other problems, not the core problems.
absolutely.
Yeah. Sounds great. So yeah, thanks for taking time on a busy Saturday morning and joining early morning on this show and enlightening us with very valuable pieces of information. And wanted to thank you once again for coming.
Absolutely. Thanks for having me here. It was a pleasure speaking with you, Amish. Excited to see where your podcast heads. I hope like you reach a more and more wider audience.
Yeah, and I think yeah, exactly right. Like a viewer number of views is one thing, but even if one episode makes a difference in like five people's life, I think it's extremely valuable.
That's very poignant.
Yeah, sounds great. Thanks a lot. Have a good
Thank you,
day.
Amish. Have a good one.
That's a wrap on today's episode of Main Street Minds. Want to share your journey with our audience? Head over to mainstreetmindspodcast.com/guest to apply.